So I'm going to present the solution in EMFTVM, and what I'm going to start off with is what is EMFTVM to begin with. It's a new tool, and basically the idea is that I'm able to compile multiple transformation languages that all have some sort of notion of rule into one VM, compose them and execute them within one session. So for now we have compiled ATL and a simple graph transformation language into this VM bytecode format. Bytecode format has rules in there explicitly, and then we can introspect on those rules and see if they can compose through inheritance or through overloading. So now, off to the solution strategy. I wanted to combine those two languages in the solution. So basically, I'm taking the spec model, and that I first want to map to a configuration model using mapping rules, and ATL is typically good at mapping. That part goes to that part goes to that part, and the implicit tracing will mesh the thing together. But it's not good, in this case, at preventing the creation of duplicate elements, like the same mode could occur multiple times. It would be very difficult to prevent that, so I chose not to do it, and to use graph transformation rules to merge them afterwards. So there's a mapping step, and then a merging step that merges all duplicates. And the idea is then to compose them together and execute them together. So a small tool bug prevented me from doing that, because the tool didn't allow me to change the mode of the model to output only to a read-write model, which I need for rewriting. So it's a small tool bug that's ruined it all for me. In any case, this is the overview of the on-off solution. Basically 5 rules, 6 rules in ATL. There are also helpers, so what you're seeing is about half of the code. There's 144 lines of code altogether. Top level rule creates a configuration from a specification and tries to collect modes and constants to put in there. So what I did is really, this transforms no more than is necessary for on-off. Observe button means that I know that there is a certain button, so I have to make it available. Mode is created on the fly there, such that the button is embedded inside the mode. And the behavior is looked up through an OCL helper, so that the behavior, which is inside an observe mode element, is linked to the right button. So, because this is done on whether a button is first or second or things like that, and I'm just comparing the strings to see if it's the same button. So the behavior always ends up with the right button in this way. Then, as an extra, observe label value is translated to something that changes the display on entry, so it's only on enters mode. And actually I saw in the meta model that there are two kinds of displays. You have an indicator and you have a display. And basically on the input side, the label type corresponds to that. So this was low-hanging fruit. In the case of ATL, I could just use rule inheritance to use either one meta class or the other, change display or change indicator. The rest of the rule is all inherited from the abstract rule. Okay, so then we get a mapping result that looks like this. Basically, modes are there, buttons are there, but the behavior or entry actions here, they end up, behavior is embedded, but the entry actions end up loose in duplicated mode elements. And those mode elements are also not embedded inside the configuration. So this is what I have to fix in my merging step. And the merging step looks like this. I have 4 rewriting rules. This is the simple GT language. All of a sudden this is graph transformation double push-out semantics. There's an abstract rule that I'm going to use as a super rule for everything that tries to find 2 modes with the same name, where only one mode is embedded within the configuration element and the other is not. I need to make this distinction because otherwise when I try to rewrite buttons from one mode into another, they keep on flipping back and forth. And this is a fixed point transformation, so it keeps on transforming until no more matches are found. So it's really simplistic semantics. Also the abstract rule is meant to optimize the matching bit, because we're using something like a RT network, same as Viatra does. Then we make it explicit. If the abstract top level rule does not match, we never look at the subrules. So that's how that works. And then the results there is like this. The actual entry actions are now embedded inside the correct mode elements.
What's your second constant?
My second constant is empty.
Yeah.
It's an empty string.
Okay.
So there are two constants there. One says hello and the other has to say nothing. So basically what I did is there were reference solutions online. So this one compares to it. The only difference that I have is that the mode on comes first in my solution and the mode off comes first in the reference solution. But this is not really specified what should come first. So I did not bother further with it. Conclusions. I found it really hard to come up with a proper quantification as you normally do in ATL. So the standard ATL pattern of just mapping a single element and mapping it to another single element and it all meshes together nicely. That fell completely in the water. I had to use entire idioms. So something like, let's see if you're in a certain mode and which button has to be there in the mode. You have to use that pattern as a whole, match the idiom as a whole, and then you can translate this in a way. But the only disadvantage is that you will likely end up creating duplicates, and that's cannot use that to converge all the mode elements from the first transformation pass. That's when I use rewriting rules to put them into one. I could have probably done it with ATL as well, but yeah, I can't really say. My guess would be that it wouldn't be as concise. So, and it was a really easy thing to do using rewriting. Okay, so that's that. 14 seconds, so maybe I can show you the code for a bit. Hey, go back. Come on. Otherwise, already started with the questions.
How did you do, or did you do button ordering and or mode ordering?
No, as you have seen, mode ordering is not part of the game. I actually have the modes the other way around. What I do is I generate them in order of appearance. Same thing goes for the buttons. I haven't solved the button ordering problem. I probably would have done it using a pre-transformation that orders the input spec such that the test cases are ordered in the right order of appearance. So what I do right now is I just generate buttons in order of appearance. Yeah, this thing is usually in the way. So just to get an idea of what the entire transformation looks like, is this the one? No, this is my attempt at the second. Let's just close that. My attempt at the first is this one. So there's a bunch of helpers that allow me to do navigation. So basically I try to put every expression that had a couple of navigations in there in a helper. So that's about half, and the other half are the rules.
Are they all matched rules?
They're all matched rules. So that's it.
Did you find time to write comments yesterday, or did you do that since?
No, I wrote those comments yesterday.
Wow.
Now I have to stick to that. Also, what I always do is keep the helpers apart from the rules, because it allows you have to switch a lot between them when you write your transformation. So.
Good reflexes to write comments.
Okay.
All right.
So we do another presentation.
Thank you.